Good to see you all still around. First day of NDC London. Happy to see you here because in the next hour or so I'm going to talk to you about Sandboxing .NET assembly for fun, profit, but most of all security. The main topic. So it's always polite to introduce yourself, right? So my name is Niels Tanis and I work as a security researcher for Veracode. It means I have a background in .NET development. I have done security consulting, ethical hacking, pen testing. And in my day job, I mostly focus on static analysis, what we do for .NET applications with our service. I'm not here to talk about Veracode. If you want to do that, see me afterwards, because today's topic is going to be about sandboxing. It's going to be like abstracted around this agenda. First, brief introduction of the agenda and of the things that we're going to talk about. Then I want to look into some third-party library risks that we're facing. What could possibly go wrong with third-party libraries in our applications? There's a lot, of course. Then we're going to dig into some sandboxing techniques. Look at how other software like browsers have solved some of the problems that they were facing and how they created the sandbox. We're also going to touch newer technology like WebAssembly, who's doing some pretty cool stuff in that space. And then it would be, we're going to move into taking a library and looking into its problems and then creating a sandbox with limited capabilities. And if there is some time left, so a week ago I did a talk on WebAssembly security sandbox as well, and I have a couple of additional demos. So if I have time left, I will go through them as well. So let's get started. Let's move on. So if we look at how we develop software, it's a big chunk of what we do, and at least that's the same for me, 80% plus. You can get that metric from a lot of different places. They say that, hey, 80% is third-party library, which of course makes sense, right? Because it's efficient. And why would you reinvent the wheel? Why would you not take something that's already there and develop by somebody else? And I'm lazy as well as a developer, right? I want to be as productive as possible, but security thoughts in my back of my mind say like, hey, but I also want to not introduce any additional risks. So what can we do about that? If you then look at libraries and the stuff that you pull in from NuGet or someplace else, you could always question yourself like how actively is the maintaining done? If it's done by people who are in the open source space and developing it in their spare time, could you expect the same type of responsiveness and security as a big company that has like 100 people doing security, for example? That's a bit of a skew. It's not balanced. So how actively is it maintained? When was the last release done? If it's like 10 years ago, you should maybe scratch yourself behind the ears, like, is it a good idea to pull this one in? And what do they do for security in general? Do you see a process? Is it easy to report vulnerabilities? Do you see stuff around, hey, do they do security testing themselves, like maybe with some fuzzing? So throwing a lot of inputs against the library and see how it behaves or if it crashes. So that's, those are a lot of things we need to consider if we pull in libraries, and especially if it's third-party libraries. And some good metric around this is a report that is called State of Software Security, and this is the only time you're going to see Veracode once, aside from the logo that's in the banner, but we produce a report each year where we take the statistics of our service, and in 2021 we had an open source edition, and one of the metrics turned out to be like almost 80% of the time developers never update libraries once they have deployed or released an application in their code base, right? So an application gets scanned throughout its lifetime and then you can see some metrics. So that's quite worrisome if you don't update the libraries. If you maybe now have a project you've released a couple of months ago, if you now look into the libraries itself, there might have been updates done because of some security issues. Yeah, it can introduce problems, of course, because same for .NET Core, .NET in general, vulnerabilities are found and are being published. And luckily, if somebody found it and maybe did a bug bounty, got some money out of it, helped out Microsoft to fixing this. This one was published 2 weeks ago. Turned out to be denial of service within .NET. Not sure what the details are exactly, but I always look up the last report to say like, hey, this is 2 weeks ago. So this already states like, hey, you need to update the libraries of your apps that are running in production, or at least have some sense of what's ending there. So this is the first thing of libraries. What else could go wrong with libraries? Libraries could get compromised and used for different purposes, right? So this was one related to a UA parser NPM package, and this is Cybersecurity Infrastructure and Security Agency that published this, where they say like, hey, we found malicious code inside this library, and The NPM ecosystem consists of a lot of small parts that make up the thing that you're using. And this is a user agent parsing library, so it will take like a browser string and it can understand what's inside. And it turned out that somebody was able to commit a change to it. And I think it targeted some Bitcoin wallets or cryptocurrency stuff and tried to steal that. And how was this achieved? By just stealing the credentials. Luckily, GitHub, NPM of course, part of Microsoft, have decided like, hey, we need to turn it up a notch, right? So that previous one was just based on credential theft, so username, password. How can we safeguard this in a better way? Is introducing an additional factor like two-factor authentication. This was October last year when these articles were published, maybe even December, where they explain in order to publish an NPM package, right now we turn on two-factor authentication explicitly. Makes it harder, right? So if your credential gets stolen, somebody doesn't have this additional factor like the token on your phone or something else, or maybe a YubiKey for that matter that you need in order to publish it. So that's what can be wrong. And another area which I run into based on a report that was done by Reversing Labs is libraries itself. Also, if you look at the NuGet ecosystem, might have some stuff inside that you're totally not aware of, like silent vulnerabilities. So what they did is they looked into the ecosystem, NuGet ecosystem. For example, there is WinSCP libraries that are like helper libraries, which have got like hard-linked, unmanaged DLLs inside of it that it uses to do it, right? So probably some interrupt that it does from .NET to call those libraries. And that library is not visible that it's inside the NuGet package. It's an artifact that's inside, but you cannot see it, right? It's not a reference to another NuGet package that you're relying on, like a transitive. It's inside. It turned out that some of the libraries have vulnerabilities for a couple of years. And there even was a implementation which is related to encryption with zlib. And it turned out that zlib has no binary you can just get or a precompiled thing you get. You need to always build that ROM from source. So for one of the libraries that they found, it turned out it had like a really pretty severe vulnerability since 2016 because it has a compiled version of zlib inside. And the only way how to identify that was looking at some heuristics of source code and how it compiled into that library. Right? So there's some stuff inside that you're not aware of. And even when you're pulling in a library that has some unmanaged stuff that happens, right, it helps out because it makes you more productive. But there's always a risk tied to that if you don't know exactly what's inside. And to illustrate all of this, like how does this build up, you probably have seen this cartoon before. And it's all referring to the all modern digital infrastructure, but you can just replace this with any modern application architecture. And we see over there that somewhere in the bottom, like some project, some random person in Nebraska has thanklessly maintained since 2003. There's always that single piece in the ecosystem. If somebody grabs hold of that and maybe pulls it out, then everything will collapse, right? Or even if you have access to a NuGet library itself, let's say you're able to control what newtons of JSON has inside, you can probably imagine how big the impact would be on the ecosystem, right? You can reach out a lot because it's a transitive dependency to a lot of things. And that makes it a hard problem to get, right? So vulnerabilities, we need to update them. There might be stuff that we're even not aware of. So is there a way for us to do a better job? That was how I started out this concept, saying like, hey, can we maybe find a way how we can reduce the risk? Reduce the risk of the libraries that we pull in, but still keeping our productiveness, right? And in general, keep in mind that breaches and hacks happen. It's just not like, it's not how, it's more like when, and you always need to anticipate that. Looking at supply chain issues, I've also done talks on that. There's a lot that could possibly go wrong. It's always good to know what's inside and what type of libraries you're using, and for that matter, anticipate this. So getting to the technology, there were some key things that I put down in order to work on this. I want to use the library without any modification. That's a key, right? So I just want to get the NuGet package from NuGet and say I want to use it as is. Okay, we maybe then take that and create a controlled restricted sandbox and a sandbox with limited capabilities. So one that has limited access rights. Keep in mind that if you pull in a library within a .NET console app, for example, the library itself always has the same access as the process has once it starts out, right? So it can read files, it can go everywhere. And that is probably something we want to have more control of. If we look at sandboxes in general, what are good examples of sandboxes and how they work? This is a drawing of the Chromium sandbox, the one that's in Chrome and Edge, and how it looks. So, of course, with the first browsers, you can probably imagine if you have a single process that renders the content, that renders media files, images, fonts. Once one of those components got compromised, the browser got compromised. So they decided to split it up to make sure that, hey, the render stuff is done separately, or each tab will get a separate process once it renders, in order to make it more secure. But there still is a need to communicate between system resources as well. So what they decided to do is like, hey, we have an IPC service, like an interprocedural service that each sandbox can call. So if there is a thing that the page or the thing that gets rendered wants to do the relation to the browser, it will be propagated to that. There's a policy engine with a policy that will allow you to have more control. And the good thing about this is that once Chrome started out doing this, or Firefox, I'm not sure who was exactly first, but those two browsers started competing, and they all want to have similar things inside. So that's cool. Even if you look at Firefox itself, they have container and site isolation, and I think that's a pretty good feature to use if you want to do, let's say, you do your online banking, and you can create one container that's exactly for that purpose within your browser. That's nice. That's almost similar as taking your mobile phone app of the bank, because it has one dedicated rule, like one dedicated function. You only use it for mobile banking. That limits it. And Firefox, there's another really cool project which is called RLBox, where they use some language features of WebAssembly, and they take the plugins and compile them back and forth from WebAssembly back to C code and then run it. That allows them to have more control over what's happening as well. And that's a pretty solid thing. It's based on WebAssembly. And another technology stack that's like evolving right now and going around pretty rapidly is WebAssembly. And there's a lot of stuff you can find around it. But one concept that has been created by the Bytecode Alliance is called WebAssembly nano-process. So let's just assume you have a dependency graph of your application, the top one. And then you have different modules that rely on that are underneath there. WebAssembly itself has control flow integrity. It means that it has some perception of what the execution flow of your application will be. And if something bad happens, it will recognize that. It also has module isolation. So each module has its own memory and cannot write across boundaries of it, which also makes it more secure. So that adding those together makes it a real solid approach. And on top of that, they're working on right now a model that you can put permissions on, and you can say you're allowed to do this or you're not allowed to do this. And this is pretty nice. As I said, if I have time left, I have a demo. I can show you some of the bits that are already made. But I think this is exactly what I wanted to achieve with .NET as well. When I was working on it, and I think it was 2019 when I had the first version of the sandbox that we're going to create. And then I saw WebAssembly mentioning exactly the same, because they want users just to be secure, and they don't want to have modules that might become malicious, as the one with the mask that does bad things, right? Having more control over it. I think that's the outcome. A sandbox in general. And then if we look at .NET and security, what else did we have in the past that helped us out securing our applications? Something called Code-Access Security. So if you might have developed the first bits of .NET, there was like that big, thick blue book of .NET Framework Security that contained all Code-Access Security aspects of it. And it was an evidence-based model where you had code that could originate from different locations, start on your machine, run from the network or internet, those kinds of like rules. And based on that, you can assign different rights to that whole system. And then there were stack walks that protected against learning attacks. So the drawing you see underneath, the last drawing here, is one that comes from Writing Secure Code. That's a book written by Michael Howard. I think it was 2004, 2005 when he published that one. It's a real good book, and the concepts in it are still applicable. Although the technology stacks have evolved, what he wrote down is exactly the same. But just consider the following thing, that you go to a library and you want to lend a book. And Carol asks Vicky, asks Sandy to lend a book. So this is like method A called method V called method S, and then at the end wants to lend a book. in order to make sure that everybody in this chain is allowed to do stuff, you need to show that you're like part of this library. You have a library card, right? You pay membership, you say like, hey, I can do this. So the librarian asks like, hey, has everybody have got like a library card so you can lend this book? Are you all members? And then by the last part, the stack walk decides like, hey, Carol doesn't have membership, so we cannot do this. We cannot force this. So the evidence will be the card itself, and the policy is the person that decides to lend you the book or not. And then the stack walk at the end would be the whole chain, somebody calling, right? This is not definitely how you would go into a library with 3 friends and lend the book, right? But it illustrates how you can see calls being like a chain of calls ending up somewhere, and then the callee or the eventually endpoint where it executes asks like, hey, are we allowed to do this? And based on that, if a module or a person becomes malicious, you cannot do anything, right? So that's exactly almost similar to what you saw with the WebAssembly 3, you saw the blue thing, which is, by the way, a code cartoon that's drawn by Lynn Clark. There's a lot of good series on that where she explains a lot of security problems and how to solve it. So Code-Access Security, if you look at it in general and how we have seen it in the past, most practical example, and maybe also the one that has been in everybody's face once it was introduced, was medium trust within ASP.NET. You configure your ASP.NET side to run on medium trust, which means that you cannot access, let's say, for example, temporary files on the system. So if you had a shared hosting system at the beginning, IIS, every website was running on that single process. If you were one app, you could just easily say, like, hey, give me all the temporary files of every other app in the system as well, right? So that was something that they wanted to mitigate in that thing. But unfortunately, Code-Access Security got deprecated since that .NET 4, which was also the obvious thing to do because it was just a memory, mutex and user memory that you could just flip during execution. You could just turn it off. There was no fuss to it, right? If you want to know which one, I got like some details on that. And also, I think the biggest problem is what there was like a big thick book. It was really complex to use. And it was like written in a way that it was, you could use it. There's a lot of stuff. For example, there was an option where Silverlight got introduced that this model would be the right fit to do, which almost is the equivalent of the WebAssembly stuff I just showed, right? It was just too complex too early, which is unfortunate. And so based on that, we need to do something different. So first, let us dig into a library that I, of course, created for this purpose, for this demo, but there are some problems inside that library. There are security issues that we want to tackle with the Sandbox. So briefly, let me show you how that library works and how it looks. To switch to the code to see where we're at. Hopefully everybody can see that it's in the back. If I increase the zoom font even more, then it will be gigantic, and I have no screen like left to type. So there is a library called Document Processor, and if you go to my GitHub repo at the end, you will see I've got these demos all including in the slides with notes that have links to all the sources that I've used, so you can just go through that at your own time, at your own pace. But it has also a NuGet config that has a local package. The document processor itself implementation, you can find it in GitHub as well. But what it does is it will process a document, and internally it will do some logical stops, which we're going to touch later on once we fixed it. But it will just take the input and the output. And in this case, if you pass on 2 files, what will happen. So we have a docs that has a schedule. We see over here the output folder is empty. If I run this one right now, just continue. Let me go to the terminal once more. I don't know exactly what it's in. So this is the start. Let's say console app. Let's say .NET run. We will get the same. So we will see over here, I'm not going to use the debugger anymore. We will see over here that it has copied the file to the output, right? So that's internally what happens. You pass a file, it processes it, which is magic, but it's file copying, and it pushes it out to the other direction. The other thing that it also can do, right? So if you go here, you see that there's just like a view of the PDF itself, just a PDF of the schedule. The other thing it can do internally is if you pass not a file name but a URL, it will do something different based on what it gets. So in this case, if you pass on a URL which refers to the website of NDC London, it allows you to write an output file as well. So let us do a .NET run again. Have I saved the file? I have not. Then I'm going to just close it, save it again, and then do the .NET run. Just make sure that you're all awake. And then we see that in the output folder we will get an HTML file, which, let me close this a bit so you can see it. It's just the content. Trust me, this is the one from the website, right? It downloads it. So what are the security issues? First of all, a URL that gets reached out to, if you would run this inside of a server context, and I, as an attacker, have the ability to control a data element that ends up in a URL, I can do something called a server-side request forgery. So let's say you have running something in Azure or AWS, and I can control a piece of input that it gets from processing. I can then get it to request the metadata service or read other stuff from other systems that the system is connected to, which you probably might not have direct access to. That's a problem called server-side request forgery. It's pretty big. If you look into bug bounties and people who have written up some cool security stuff, the 9 out of 10 times server-side request forgery is the first stepping stone that they use in order to do more things, right? So that's a problem. And that's all based because the library decides, hey, this is a URL, let's grab that data from the internet, which is not a good idea. The other thing is that if we look into the code once more, it writes a file to a location. What if I give it just an arbitrary location? Let's say I go up one folder. So not say, hey, let's not do this, but let's put it into output. Make sure we uncomment it. Save it. Run it. We will see that we will get a file in the higher folder. And this is something in security which is called a CWE73, a path reversal issue. So if there is a data element within your application that constructs a file location where a file gets written to, I might have got a possibility to overwrite files or to put files where they don't belong, with all side effects to it, right? So those are two security issues that are inside this library that we cannot control because we want to use the library as is. So can we do something about that? So let me quickly go back to the slides and let me recap what we just saw. And one thing to keep in mind, I want to use the package as is, but there's always a disclaimer. And the disclaimer is like, if you have a library from NuGet, you might not be allowed to look into its internals because you're not allowed to decompile it, right? There's a whole license you comply with if you use it. So if you're planning on doing similar things as I did with a library, make always sure you check that license before you do it. That's why I wrote some stuff myself without anything tied to it, because you might not be allowed to reverse it, decompile it. And we want to change the behavior. I want the library not to open a URL location once it gets hit by a URL. And I also want to have it limited where it writes files to. So 9 out of 10 times, if you run this in a cloud environment, let's say there's a cluster of containers that you would have run somewhere, you could always decide like, hey, what if I just take away the egress, so the ability for the container to reach the internet, then the problem is solved. That's one layer. Or if I lock down the files it can write, like the locations where it can write files, that's also a layer. What we're doing here is creating an additional layer in code, right? So the mitigation will be on top of each other. And I think that's a good thing from a security perspective. You always want to have additional layers of defense. So that's the goal. How can we achieve this? And we already, I touched it a bit at the beginning when I was talking. What can we do? So with .NET Core introduction, there was only a single app domain. And you could do some fun stuff with AppDomains in the past because Code-Access Security relied on that. There was that whole plugin model where you had like a game, you can create ends, and you could load that into memory and give it limited rights. That was all AppDomains. Luckily, they did expose some of its internals based on assembly load context because it replaces the isolation mechanism that was done by AppDomains, and it conceptually allows you to load, resolve, and unload assemblies. So what you've seen in the beginning is there were demos. I think even it was David Fowler at one of the NDCs where he showed there's an app domain, there's a load context, and you can take multiple versions of Newtonsoft JSON and have them running in a single ASP.NET Core application without any fuss. So that gives you more control. It also, if you look into its documentation, explicitly states it gives no security guarantees. And we're going to use it for that way, but because, as I said before, all code has got full access, the same as the process has. But it does give us control over what's get loaded, and that's exactly what we're going to dig into. So, if we look at the app we saw before, let's move and let's decide on what we're going to do. First, we need to make sure that we are able to sandbox the library itself, so we need to make sure we have an interface project that we will use to wrap around the Sandbox project, like the document processor. Then we're going to remove it to a library. And that library will have the reference to the document processor, will have the implementation of the interface, and then we need to write something that will publish a self-contained version of that library. And I'm going to explain to you later what that means, but it has to do with like having all its dependencies in a single location, right? I mentioned to you with assembly load context, we can influence what gets loaded. So now I want to have all my eggs in a single basket and then take out what it's not allowed to use. And that's what we're going to do with that self-contained deployment. So let's try, let's see where we're at. So if you look at the demos, I have a start, a middle, this is the middle stage of the demo, and then there's the end result, which is called end. Hopefully self-explanatory, but it gives you the ability to go through everything I'm mentioning here. And when I was doing this talk in the beginning, I also did the whole transition in coding during when I was talking, and that was a bad idea, because if you're coding on the spot, people look into it, you're doing this wrong, you forgot to save that file. That's always what happens, right? That's not what we want. So first, let me show you. So there is a library implementation, and we saw at the beginning we had a processing logic that has just this operation. So there's just a single marker interface, nothing fancy, that we're going to use for that. Then that project will be referenced by the console app, right? So there's a project reference that will just take the library itself. There's no reference to the document processor in this library anymore, because that logic moved to the library implementation. So this is the project that has a reference to the package that we're going to using, that we're not going to change, right? And there's the interface that we need. And if we then look into its implementation, we will see it's just almost a pass-through of what we've seen before. And that first line that I'm doing here, that type of, has to do that I want to show you where types get loaded from, because that's part of our solution. We want to load stuff from a different location and influence how it internally works. So that's exactly what we're doing here. So we have this, and there's no reference of the console app to this location. The console app only knows the library, and on top of that, there is a isolated load context implementation, which is a derivative of WebAssembly load context. This just uses the basic blocks. You don't need to fully understand it, but what it does internally is it will try to resolve. There's two methods that are responsible for loading managed code and loading unmanaged code. And we have an exception to one type that we don't want to have loaded because we want to share it. Let me put that one on silent. That's the only thing, that's the exclusion. That interface type is the one that's going to be shared with both of the projects. And the other one, and then the load context itself will take care of the right type getting loaded. So, and what we see here, this is then the end result. This is used to be the console project we saw before. I'm also showing you where HTTP client originates from. That will be explanatory once we get there, once we have executed it. Then we say load context relies on this DLL getting loaded, and I'm only interested to exclude this processor interface. I'm going to create an instance of that, and then I'm just going to call process documents on it. There's one thing I did not do, which is publish. So the self-contained publish is needed to get there. I haven't done that. It's in lib. It's a batch file. So what it internally does, it will just do a publish. I can show you. So library itself is just doing a publish to a folder, self-contained, and it targets my machine. So it also includes all the managed things I need on my Windows machine, right? And then we have this output folder, and then we see all the DLLs, which is like there's some bouncing castle crypto. So the library itself has a reference to iText, which you can use to do PDF generation, because that's like a big dependency graph that has a lot into it. So you can see this is all what you get if you publish that app. What happens if we run it? Let's not do the debug, but let's just start out. Console app. Make sure that we have this. What am I doing? Hold on a second. So in the program itself, so I'm just processing a document and I'm copying it from the doc schedule to output schedule. Output is empty, right? So let's say .NET run. And there's two things that I quickly want to show you as well. Is it still waiting? No. Hold on a second. It's Control B, right, to collapse that one. No, it's not. Okay, cool. I mentioned to you I'm interested in where types get loaded from, right? So this is the console app itself has HTTP client, which comes from the shared folder where the .NET framework resides. And the other call we see over here is my processor has the same, but it only gets it from the published location where I put those full deployment of that library. So what we see over here is that we can do this, and we can still open and copy the file, and we can also, of course, still do the same call to HTTP client and say, hey, I want to load these files. Did I lock this one? No. So let's do the other one underneath just to show it that I'm here. Run. We will see it will produce that HTML file as well. All right, so it fetches that content. So technically it still all functions the same. We put the abstraction in, and let me go back to the slides and quickly talk through what I've changed, because I tried to create some nice diagram of it to explain to you like, hey, what's happening internally. This is how we started out. We had a console app that had a library that it was next to it, and underneath that we see all the base class library stuff that we rely on, which is related to HTTP. We do some stuff with text.json, IO, there's a whole list, right? And what we have achieved with the previous demo I just showed you is the following thing. We created the load context itself. We put the library itself into the document processor into the library implementation. And the load context is responsible for creating an instance of our sandboxed load context. And then we see on the left-hand side has its own .NET libraries that it uses, right? The system.io, and the right-hand side has the same. And that's, of course, part of the trick that we're going to do. So it allows us to control what libraries are used by, in this case, our document processor. So when I first started out mingling with this, it was 2019, I thought like, hey, could I just not like remove types, take types out of it? So let's say, hey, HTTP client, it's not available anymore. For some, if you do it, at least with the implementation I have right now, there is a control flow that expects HTTP client to be there. So it will just break. It will just throw a runtime exception if you do that. So that was not an option. And what about trimming, right? With .NET 5, a lot of trimming was introduced as well. Even with Blazor, we want to have a minimal set of .NET DLLs downloaded once we create our app. So maybe trimming can help us out, but trimming is not supposed to break our applications as well. And that's in essence what I want to do. So the link itself does it for us. And I want to have something that's more rigorous. I want to just take care and mingle with stuff at a different level. So what I decided to do is that I moved into a library called Harmony 2. And Harmony is a library that allows you to patch, replace, and decorate .NET and mono runtime, methods at runtime. And of course, this would have been a lot better if you mingled with the IL itself and made it persistent in the DLL. But this is the best alternative, and it gives you more control because it will transpile at compile level and it will rewrite some of the stuff. What we're seeing here, it's available on NuGet and it's being developed right now. So that's the additional layer we need, and that's the additional thing we need to do in order to create our sandbox and to create stuff and limit things that we're going to do. So let me go to the last demo part, at least of this, and show you how you can do it. And now I also need to confess something. These two apps, or the three apps you just saw running, are .NET 7 apps. The one that I'm going to show you where the sandboxing is in is .NET 6. And it has to do with Harmony not being, like, it didn't catch up with .NET 7 yet fully. And for some reason, it did not patch. So you can probably imagine if you're preparing for a talk and you're doing your demo and you're doing your last demo, which is like the big fireworks, it should all work. It didn't work. I thought, like, what was the last thing I changed in this? Oh yes, I moved to .NET 7 because I gave this talk in October of last year. Or maybe it was November. I think .NET 7 was released, but I decided, nah, let's not do the upgrade right now because it probably breaks. And that's exactly what happened. So let me open up the end solution and show you what we're doing. So all the magic itself and the patching and creating the sandbox is done in library. So what we see over here, Harmony has got some really rich documentation and it allows you to show it. Just to quickly show you, this is .NET 6, right? And the console app is .NET 6 as well. I'm still keeping an eye. I did see the issue. It has to do with one of the mono dependencies that did not compile through, or that changed for some reason that they need to fix. So hopefully they can get it fixed quick. Now my Control B is also working again. It collapses the side thing. Cool. Harmony itself can be instantiated by just doing a static call to it. And I'm going to say instruct patch all. And as you have seen in the code, when I opened it, there are a couple of patches. First, there is an HTTP patch, which Harmony itself has got a specific way of patching. And there's a way you can say, like, hey, prefix patching, which means this will get executed. It's almost like expect-oriented programming where stuff gets injected and will be executed in front of it. That's exactly what this is doing. And I'm going to patch HTTP client. And once the call get stream async is used, that's what my library uses internally, I'm going to say, hey, you're not allowed to use this. You're not allowed to do this call. And it will just stop. It will throw the argument exception. That's one. The other patch has to do with the copying, right? So it does system.io.copy. And what I'm doing here is defining a signature as well. I want to patch this. This is 2 arguments. And then I'm going to canonicalize the path. So I'm going to say, okay, so you want to write a file to a destination location by creating its most pure form. I know that that's the path, so any traversal things will be resolved on system level. And then I'm going to say, I want to make sure that the path that you're writing to at least is part of this folder or something underneath, which at least locks down the risk of writing files up or so outside the directories. Then we can say, okay, write it out. And if not, it's not allowed to use to do that. So those are the 2 patches. So right now, I first need to publish the library again for the self-contained stuff we saw before. So that's the pub that we're going to run, which will show up a lot of things. Here, well, includes Harmony right now, all the things that I have that I need for my machine. And once it's done, let's go to the console. And let's look into that one. Collapse it once more. So, scrolling up, because there's a couple of things I want to show you as well. So, first we're gonna do the copying of the files, or let's do the HTTP client. That one's already commented. So we're going to create the instance, right? It's exactly the same. It's referring to the DLL. It talks out. So let's say we're going to request ndclondon.com and we're going to write it to the output folder. So the one that we were supposed to be able to do in the beginning. It runs. It starts. It shows us, hey, the types are being resolved. Those things are still in. And what we see over here is that we get our exception because we do this call, and it's done by the library internally, right? So we didn't mingle with the library, but we mingled with the .NET framework that's underneath it. And we said, like, hey, you're not allowed to do this. Second demo would be taking the file copy, right? So let's say that. First, we have the happy flow. Or no, this is the non-happy flow. Let's say we're doing the happy first. Let's say we're writing it to output. I know this is probably done. Now I'm trying to mix up because I believe my Mac is case insensitive, or Windows is case insensitive, and Mac is case sensitive when I first did the demos. We have the output, so it has created Niels, right? This is the file. To prove, right, this is the same we saw before. All good. So, yes. Now let's change it and let's write outside the folder. What you see is still done there. Let me remove this. That one was one from my test before, so let's make sure that it's a clean slate. And let's just give it another name, then you know for sure that I'm not joking. So let's say Westminster. Save it like that, run it. Does it build? Yes. Just to be sure. Does it run? And then it comes with false. You're not allowed to write files outside of that folder, right? Because it has that check of that path that I showed. Creating its most pure representation, then deciding if it's not in or is it. If I put it inside the output, did I save it? Yes. It copies it, right? This is the file. This is the file that we just created, but it created to the output folder when it's allowed to write. So yes, this works. I'm happy. So you could say, Niels, but are you joking? Or like, I want to have proof that the other parts are still working. And that's probably a piece of code you already saw commented. Let me uncomment it before we go through. So what I'm doing here is I'm using exactly the same functionality as the application was doing. Let me turn this one off. So this is comments, it's not going to execute. So now we're just going to say, hey, give me an HTTP client, do that call that we patched, return that data and write it to, and do the copy to async, which is the other method I patched. Right, so if I now say .NET run, close it, just to be sure that I save it, yes, .NET run. We will see, and it has saved a file called NDC Sydney. You can probably imagine where I also gave this demo, but this is the file that was get by the HTTP client in the normal context, which still has it present, right? We didn't mingle with that. So that proved that our concept has worked, and that we need to shovel around a lot of code and do a lot of things. Totally aware of that. So what's missing in this, or what do we want to change? So looking at in general, this picture, you saw it before, right? So we still use the same concept, but what we did with the .NET framework that was used by the isolated load context is we have replaced it, and we put the patches in based on Harmony. And as I said, I would rather maybe have the IL rewritten, that it's inside the libraries itself, and the runtime, of course, is the best alternative. But it's not in a thing that it's easy usable. You probably have seen the code, the stuff that I need to do. There's definitely something to the developer workflow I need to fix, but I've got some good ideas about that. So I said, if I have plenty of time left on side of demos, I want to show you the same thing, but then with WebAssembly, because I think it's really cool and this gets me excited. So if you look at how .NET is run on WebAssembly, we can probably imagine the following picture. So we have some user code IL that we wrote ourselves. We rely on a base class library. And then underneath that, there's the execution engine, or VES as they would call it, which is our CLR that takes care of our execution, right? It bootstraps on .NET. It starts out. It will run the code that we've written, the IL, and it will execute it. And it's run on top of a host. How can we run .NET on WebAssembly? We can, of course, take the execution engine, compile it into WebAssembly, right? And then host it inside of the browser. This is, of course, what exactly happens with Blazor WebAssembly. So what they've done, what Steve Sanderson has done in the beginning, he took the virtual execution engine, C code, took a tool called mscripten to create a WebAssembly representation of it. And once you do a .NET New Blazor, you start it out, the first hit you will see, it will download all the DLLs from your application, all the native, or the .NET framework code and everything it needs, and it will also have that WASM file, which is the CLR, the process, how it starts. So this allows us to run .NET on WebAssembly. But I want to run WebAssembly or .NET on WebAssembly outside the browser. So I want to eliminate the browser component that's underneath. Are we able to do it? Long story short, there is a thing called WASI, which is belonging to WebAssembly. If you look up the bytecode lines, you will find a whole specification. But WASI is the equivalent of Net Standard to some degree, right? Because with Net Standard, we were allowed to converge base class libraries into eventually having one .NET framework, right? With all problems tied to that. But it is the same, but it's a system interface. And it's a POSIX-based model, and it allows you to assign capabilities to specific calls and allowing stuff to happen or not, right? And that's exactly what we're doing with the sandbox I just showed before. But this is also possible with a runtime. So WASI runs on every WebAssembly-based runtime. So WASMtime is an example that does it. So you can take a .NET application, compile it into a WASI-compliant app, and execute it on WebAssembly. And this is the thing that Steve Sanderson showed last year at Build, which is a conceptual WASI SDK, as how they call it, and they're not committed to doing anything concrete with it, but there is movement on it done. Right now there's even an issue that they're working through, which includes more of the stuff getting implemented. Because as you probably will see, and I'm going to switch to the last demo, I'm going to take my .NET application, I'm going to run it on WebAssembly, and then I'm going to run that WebAssembly inside another .NET application, which is a double 3 layers thick stuff. It's not performant, it's not the right thing to do, but it's fun, and it shows that there are similar concepts. And the whole WASI stuff and the component model and the nano-process I showed before, I think it will create a rich ecosystem where you can take a module that's compiled with Go, you can take one that's compiled with Rust, you can have a .NET runtime that's the host for all those modules, and you can compose composite applications and have control over what library is allowed to do or not. So that's pretty cool. So let me quickly show you the demo. So I was thinking about like, hey, do I have time left? And yes, I have. So let's create that demo. And I just took the one from last week. And then it's called .NET on WASM on .NET. I could not come up with a better name, but I will talk you through a bit what it is, because you probably will see similar concepts. And yes, this, I will warn you, this is a lot of code. Don't need to understand it fully, but it will show you what we can do. So first we have a guest program. And this guest program is copying a file, right? We're in the same space again. It's not any fancy stuff, but it just takes input from in this case, environment variables. So keep in mind that WASI itself is not fully implemented, and also the component model should get us a tool that allows us to describe components and how to interact with them. And right now I'm misusing environment variables to get stuff into the module, because otherwise I cannot communicate to it. But there are implementations for Rust and for Go that have the full interface generation done that works. But in order to keep it, I'm just taking, as you probably see here, I read it from the environment, right? Because I just need to do that. And then I'm just going to copy the file, or I'm going to say fail. And this can be run inside a host. And a host has a lot of things. Hold on. Move to recycle bin just to make sure that we're in it. So I have a file in my temp folder that I want to copy to the root file, or to this folder where the application is run. I need to do some stuff with WebAssembly. I need to instruct. Like, hey, these are the environment stuff that I want to set. I want to quickly comment out these two because they allow us to show like what happens. Then we need to do all kinds of things, like we need to have an engine. I'm going to load the WebAssembly module. In this case, keep in mind, there's a WebAssembly file that contains .NET DLLs inside of it, and all the stuff it needs to bootstrap, right? So the virtual execution engine, everything. And then we're going to say in create one, and then execute this. That's exactly what it's doing. And at the end, I'm just checking if the files are written or not. So let me see if the file is still there. It is. Cool. So if I now go to the host project and run it, It's not working because I changed something. Hold on. What is it saying? It's not. I made it. Yes. Yes. Thank you. I think this is the one, the try catch. Oh yes. It's even the IDE that shows it to my face. It's like, oh, that's why we have good IDEs. Right, let me clear this one. Let's say .NET build just to make sure that it's all good. Yes. So I put in some instrumentation, it's writing out console stuff, but if we look into the folder itself, we see that it has not written out the file itself. And that's because by default, WebAssembly runtime doesn't give you access to folders. And that's what you need to do with the stuff you saw earlier, and that's the pre-open directory one, right? So in this case, I need to explicitly point them out and say, hey, I want you to have this one, to have the environment variable open. I need to have open up the pre-directory temp, and I want to open up this directory, giving it explicit access. And now we see it has copied the file that comes from the ctemp, right? Because I gave him the access rights. So this, yes, there's a lot of code. Maybe it's a bit short to fully understand what's happening here, but this shows that there is a lot of potential. And right now they're working on doing sockets and also the component types and the stuff it needs. It needs to be like driven by something they call with interfaces that describe how a component behaves, what's inside, what it needs, what are the access stuff it needs. And then the engine that executes needs to define a policy, right? So it's almost code-access security policy-wise where you can write it down. But the difference between this approach and what we have seen with .NET failing is that this is written top-down, right? So there are some basic stuff that's in. It needs to grow, it needs to become bigger, right? But I like the fact that they opened up and they showed this, like, hey, this can work if we want, but we need to maybe do a bit more behind this. Another thing, for example, so the sockets, cloud native that happened in the US, I think it was October, November, there is a WASM track where there is like one person from Fastly who talks about the whole evolution of this. And they are working on sockets right now because that's the next thing, that you can have a socket and limit it and say like, hey, you can only reach out to this machine or this URL or this IP. But the thing that's inside of the environment right now is something called fuel. Could you probably imagine that if a library becomes malicious and wants to compute a lot, it will consume up a lot of fuel. It will take up a lot of resources. With WebAssembly, you can limit the fuel that it consumes. So it's a logical representation. I believe like one operation in WebAssembly itself will be one fuel that it consumes, but in the host you can also say I want to consume up 20 fuel. So it's not that it's completely tight, but it gives you control. So let's say for some reason that increases, you can say cut off. I don't want you to execute. And that's a demo that I also have in, but I'm going to skip it right now. But you can see that it will start and it will just stop the execution and say like, hey, this is not good. So there can be an additional layer of defense, right, for compute as well. I think that's pretty cool. Because with like 5-6 minutes left, let's wrap up a bit. So as I said, with the whole WASI stuff, I'm excited about this. The talk I gave last week should be at NDC Security should be published as well in the next couple of weeks, that you can see we do the full story and like how it starts out, because it's probably too much to all cover right here. But I think this is cool. And looking at what we have done before, conclusion. As I said when I started out, please update your libraries. Be aware of what versions you're using. Make sure you have the latest, greatest. Keep an eye out on security stuff, on bulletins that are published, in order to make sure you're on the right version. Security should not be an afterthought. And that's of course the security person that comes into me like, I develop stuff, but please, you cannot like do security at the end saying like, hey, I'm wrapping it up. No, some good threat modeling would make sense. Like what are the risks my apps are facing? Maybe some analysis, static analysis, dynamic analysis, maybe some fuzz testing, depends solely on what your threat model is, but you should integrate it from front to end. Know what libraries are used, what's inside. right? Be aware of those things you probably are not aware of. That's inside that we just get for free, and that will be part of the application that executes. And then getting back to the concept of the sandbox I showed, I would really love to have some kind of maybe a CLI tool or a source generator that will take care of all the heavy lifting, that you can just say, hey, this is a package that I'm using, and I want to create a sandbox around this. And also maybe some default policies that you say, like, hey, you cannot reach out to the file system, or you can only take this folder and read from it, right? That's the whole policy stuff. That would be helpful. And have some basic implementations on that. That's something I still like, if I'm working through it. As I said, first I need to fix the .NET 7 problems that we're facing right now with that library, and then we can move on to this again. If you're interested in seeing more about the WebAssembly stuff I showed, then the using WebAssembly to run, extend, and secure your application is the one that I gave last week at NDC Security, and should be up in the next couple of weeks as well. So with that said, all demos that I shared with you are in my GitHub repo, NDC London Sandbox. You can reach me on my email and on Mastodon on that account as well. So yeah, that's it. Thank you for your time. And I think we have time for questions, 5 minutes. So go if you have questions.